Hello everyone, we are back with our weekly features of the week. In the first video of the 2022, we will get a close look at a very cool feature that you will find in the 2021 version of Monolix released last month. If you still haven't downloaded it yet, you can do it on the Leaks of Download page. The new feature we show you in this video is the generalized auto-initialization function available in Monolix. Previously, the auto-init algorithm was available only for models from the Monolix PK library, and now it works for any model. And yes, you heard well, any model, even your own custom model for a complex system. Before I present you how it works in practice, let me make a short recap of the basic information on the auto-init for those of you who never use it. The Trick Init Estimates tab in Monolix helps to find a good starting point for the population parameters estimation task. As explained in detail in the feature of the week number 7, the goal here is to find good initial values, not perfect ones. By good, we mean such that the model fits roughly the individual data and represents its characteristic features. In the 2019 Monolix version, we added an automated method to find these initial values, but it was available only for models from the PK library. In the 2021 version of Monolix, this algorithm has been improved and adapted to work with any model. It means that it is now available for models from the Monolix libraries and for custom models written in the MLXtran language. It also works for discrete data, multiple observations, and for joint dataset with continuous and non-continuous data types. For more information, you can check our documentation page. You have the link here. Now, let's see with some examples how this new auto-initialization works in practice. In the first example, I have PK data for a parent and a metabolite. Using the log scale on the y-axis, we can clearly see the two slopes of the elimination phase. It means that data should be fitted with a model with at least two compartments. I already selected such a model from the parent metabolite library. We can see it has two compartments for parent and one for metabolite. This model, with the default initial values, does not capture the two slopes of the elimination. So we can say that these are not good initial values. So now one option is to find better fit by changing the parameter values manually. However, this approach can be very time-consuming and difficult for complex models with many parameters. So another option is to use the automated initialization method. And in this case, a better fit is found in a few seconds. So what happened when I clicked on the button Run? The auto-init is an optimization algorithm. The cost function that it uses is a complex weighted sum of squares of residuals to assess how well the prediction fits the data. The algorithm starts with the current initial values that are given in the Initial Estimates tab, and then alternates two optimization steps, global and local. In each run, at the global step, the algorithm samples the parameters and finds the optimal values. This result is a set of currently optimal parameters, and it is passed as a starting point to the next step, Nerder-Maet optimization. Then, values estimated by the Nerder-Maet algorithm become new initial values for the next run, in which the procedure is repeated. The auto-init algorithm stops when the current run does not improve the cost function by more than 1%. Let's now go back to the interface and see more examples how to use this feature. When you run the auto-init, previous parameters are saved automatically as a reference so that it is always possible to restore them. Moreover, by default, the algorithm uses the data of the first 12 individuals. This limit is set by default to make the algorithm faster in case of large dataset. Here we see that the fit is not perfect, but it is good enough because it captures the two slopes of the elimination phase. So let's set these values as initial values for the estimation. And I have now here the same project, but with the results of the parameter estimation task. Let's see the VPC plot. It shows that the absorption phase is not captured by the current model, and we can clearly see that we need a double absorption process. So to add the double absorption to my parent metabolite model, I already wrote a custom model. Now, after loading a new model in the Structural Model tab, I am transferred to the Initial Estimates tab, and the parameters that are common with the previous model are kept. Here, these values were found with the auto-initialization, and as previously, they capture well the two slopes of the elimination phase. But let's look closer at the absorption part. I can set the same limits on the x-axis, and I can limit the grid to C interval only between 0 and 20 minutes. The double absorption process is clearly visible in the observed data, but not in the model predictions with the default initial parameter values for the absorption part. So let's see if the AutoInit algorithm can help. I click on the Run button, and yes, I get a better fit that captures the double absorption. Of course, in this example, the double absorption and the two phases of elimination are visible from the very beginning. So I could have started with my custom model and then use the auto-initialization to feed the absorption and the elimination at the same time. So let's try it. In this project, I have my custom model with the double absorption and the two compartments and the default initial parameters. We see in the charts that the prediction shows only one slope in the elimination phase and simple first order absorption. So let's run the auto-initialization. In this case, the double absorption is captured, but the elimination phase is not. The final slope is completely flat, which is not very realistic. Luckily, in Monolix, it is possible to help the algorithm find better values. We need to make it focus on the elimination part. One way to do it is to run the algorithm using only individuals who have very pronounced two elimination slopes. For example, let's use only the last four IDs from 97 to 100. When I click on the Run button now, the algorithm starts from the current values, which already captured the absorption phase, and uses measurements of these four IDs to find better values. Now, the model prediction shows the two slopes in the elimination phase correctly and the double absorption for the parent and for the metabolite. So, the take-home message from this example is that selecting representative individuals can guide the auto-initialization to find good parameters, and this is even more important in case of high inter-individual variability in the data. Let's look at another example with a TMDD model. It includes the Michaelis-Menten elimination and two compartments. The observed data shows two inflection points, here and here. Let's run the auto-initialization with the default selection of the first 12 individuals. We see that the first inflection point is not captured, and this is because of the high variability in the data. The AutoInit tries to fit one curve to measurements that differ a lot from one individual to another. So instead of using 12 individuals, let's use only one, which we think is the most representative. I select individual number 10 and click on the button Run. Now the AutoInit finds a good set of initial values that capture these two inflection points. Let's look at the last example with a big data set. In this case, if you select many individuals, the AutoInit procedure may be quite long. But there is a pop-up window that shows how the optimization cost function changes from one iteration to the next one, and you can stop the algorithm at any time. To sum up, the AutoInit is a very powerful and fast method to find a good range of parameter values that make the parameter estimation task faster and more efficient. In some cases, it may need a bit of guidance by selecting data for the most representative individual or by using it few times in a row on different individuals. So thank you for listening and see you next week to discover another feature of the new Monolix Suite version.